Thank you very much, Mahtab. Nice to be here. It's certainly an honor to be hosting this event with four very bright and intelligent panelists. I will introduce to you very shortly, and then we will dive right in. Let me first tell you a bit about myself. I'm a journalist currently working with the BBC. My focus has been covering the climate crisis and the interests, the political and economic interests at play in trying to inhibit our will and our focus in tackling this crisis, and also environmental issues relating to sustainable development, I suppose, of which, of course, renewable energy is a big part of. After over 25 years of working in this field of journalism, it's the challenge of overcoming the climate crisis that has become a passion of mine ever since the 2015 Paris Climate Change Conference, which I was covering at the time. The euphoria that followed the Paris Agreement, as many of you might remember, was magical, but became slowly diffused by the disappointments of subsequent climate change conferences in Morocco, Germany, and the last one in Poland, where the will of world leaders to tackle the climate crisis began to erode, especially which had a lot to do with the outcome of the 2016 US elections. This only firmed up my passion to carry on using my skills and experience as what I used to be a political and social journalist to understand and convey to our audience the challenges we face today in order to stop the world from warming over 2 degrees centigrade and achieve net zero carbon emissions, hopefully, by 2050. So with me today are four individuals who are working towards this objective, each in their own ways, in which the case of Elham Hassanzadeh, entrepreneur and former World Bank advisor, is to find a commercial solution to a clean energy transition, especially in Africa. Elham, can you tell us a bit more about this and the other ventures that you're involved in?
Thank you very much, Siavash. It's an absolute pleasure to be here. Thanks for the MENA Women in Tech for having me here today. Well, for those who know me, I've been a fossil fuel sort of player. But out of the guilty conscience, I made a swift transition to renewable energy, trying to be less less of a contributor to the pollution of the world. So my recent involvement with the poor income countries or developing countries is actually related to a visit that I recently had to Africa almost 2 years ago, where I met a lot of investors and project developers that were trying to bring energy access to low-income and rural areas in Africa. Well, there I just realized that there are, and you will see it firsthand, that there are people who are living in absolute darkness once the sun goes down. And to me, it was an absolute surprise that we are living in the 21st century, and with all the advancement of technology, there are still people who do not have access, either do not have access to energy, or it's, there are ongoing frequent blackouts that would impact their day-to-day life and businesses. So I'm here trying to see whether through use of any sort of technological storage facilities, including battery, hydrogen, or a combination of both, this problem of intermittency of the electricity in off-grid systems could be resolved.
Great, thank you for that. Next, we have Ali Safari, a nuclear engineer who is now turning to find ways to make our power grids change in order to take in new and clean forms of energy. Ali Jan.
Thanks so much for the invite, and actually it's an absolute pleasure to be speaking. I trained as a mechanical engineer, and then I fell in love in the energy transition back in 2014. I thought this would be the biggest crisis that we would have. And naively, I thought nuclear was a solution, was the cleanest form of generating electricity. So I did my master's in nuclear engineering in Cambridge, and then I went to CCFE, Column Center for Fusion Energy, to research fusion energy as well. But, after doing a lot of research, I came to the conclusion, actually, it's such a long way to bring fusion to production. So the challenge or the intermediate solution was renewables. And at the time, the bottleneck in bringing renewables on this scale was unleashing private capital. So I went and worked as an investment analyst in a family office called Low Carbon in Mayfair in London. We focused on subsidy-free solar projects, which essentially was making renewables compete with fossil fuels. At the time, I came across a problem which I'm trying to solve right now. We have this sort of transition in the energy industry that both the supply and demand has been disrupted. The supply is being disrupted because of renewable energy supply, which is discontinuous, is probabilistic, but also the demand has been disrupted because of, for example, electrification of heat and transport. And then the grid, the grid which was designed in the 19th century sits in the between. And the grid don't have the capability to operate in this future of energy transition. So I set out to solve this problem. I was invited to join EF, Entrepreneur First, which is like a leading talent investor based in London. Then I founded Farad.ai, and then we got numerous different sort of accelerators. And right now we are a tiny startups, but we are sitting in between multi-billion-dollar energy companies, helping them and actually already adding values to them with the grid analytics platform that we have developed. And then our ambition is, how can we bring more renewables to the system? How can we decarbonize or accelerate the decarbonization process with using analytics and AI, basically.
Thank you, Ali. Then we have Samira Farahani, who's an expert on how to make smart energy systems that are suited to storing and moving renewable energy. Samira, can you tell us a bit more about that?
Sure. I'm also very pleased to be actually part of this webinar tonight, and thanks for the invite. And also it's great meeting you all, amazing people doing all the great work towards the cleaner world, let's say, because it's not only about energy, but it's about our environment and our food and everything else. So it's actually everything that's going to be changed. So by studies, I did systems and control. I got my PhD in Delft, also my master in Delft. And then after my PhD, I've been focusing on modeling and optimization and concept design of different kind of energy and utility systems. And in the past 4 or 5 years, my focus was more specifically on smart systems, smart buildings, and in the last 3 years devoted really to design of energy systems, focusing on renewable energy, focusing on different energy carriers in the system. So really covering the whole supply chain, looking at the different production methods, different technologies, transport methods, storage, and everything. And yeah, tonight hopefully I will have a chance to tell you more about how we can clean and decarbonize our energy system.
Clean up the world. And last but not least, joining our panel today is Rezazadeh, who works at Siemens Energy with the heavy and, in my opinion, noble responsibility of helping fossil fuel companies develop green and low carbon energy solutions. Matin.
Thank you. Thanks, Siavash. Hello, everyone. I'm very much pleased to be here today with all of you, and thanks for the invitation. I'm honored to be part of this great group discussion about the energy transition and the role of renewable power generation in order to really decarbonize our energy systems. My name is Fatemeh Rezazadeh, or Matin Rezazadeh. My friends and family call me Matin, so feel free to call me Matin during this call as well. It's been more than 2 years that I am really active in the area of energy transition, especially because I'm coming from an organization or from a sector that is really struggling to reinvent or redefine themselves in the advent of transformation that in the energy industry that is happening. That is something that I'm driving at Siemens Energy. Currently, I'm driving the carbon capture business for Siemens Energy, and I'm also part of the UK government advisory group in order to really define the right deployment strategy and also right business model in order to deploy carbon capture technologies in this country. I'm very much passionate about energy industries. All 16 years of my working experience was dedicated in the energy sector, and I have a great pleasure of driving this type of technologies and also these projects. My mission, or something that really wakes me up in the morning, is the real desire and the aim to help everyone that lives in this planet to have access to clean, reliable, and affordable source of energy, even free of charge. It's a kind of basic human need, that to have access to energy and electricity in order to really sustain our life. And that is something that really drives me toward decarbonization, because if we really want to have access to reliable and clean source of energy, we really need to have it in the context of decarbonized energy system. By background, I'm an engineer. I'm a mechanical engineer. I study in Iran, my bachelor degree at Gilan University. And I have a master's in energy from Hayat University, and got PhD in low carbon power generation with focus on carbon capture from the University of Leeds. I'm very much excited to our discussion, and I know that we are going to have a very interesting conversation around this topic tonight. Over to you, Siavash.
Great. So it sounds like we all agree on the need to tackle the climate crisis by transitioning to a future where fossil fuels remain under the ground where they belong, and clean energy is all around us and hopefully cheap and affordable to everyone. The differences of opinion you will hear today are about the different ways and different approaches we can take to reach that objective. So for the purpose of a more dynamic discussion, let us for the time being put aside what we agree on and delve into what makes each one of your jobs unique. So Matijan, while I have you here, let me start with you. You're working to make possible the idea of having a hydrogen-based economy rather than what we have today, which is a carbon-based economy. So as far as you're concerned, is hydrogen energy the magic bullet that we're looking for to rid ourselves of fossil fuels? Because in any case, as far as I know, over 90% of hydrogen that we're producing now is from fossil fuels. Am I not right?
Absolutely. Yes, you are absolutely right. Even over 95% of the all hydrogen that is produced today in the world is by fossil fuel bases. And yes, I would say that really the need for hydrogen, or something like hydrogen, which is a renewable source of power, in such that it can be produced by a renewable power generation, of course, alongside the fossil-based power generation, but it doesn't emit any CO2 burned. And also it can be used as a means for storage, for instance. The reason that we are looking into hydrogen, for instance, as a new economy, or as a driver for energy system, is that if we really want to decarbonize our power generation or our energy landscape, and when we are talking about the energy landscape, it is not only the power generation, it's about all sectors in our economy that they are using one sort of energy or another in order to really drive and operate. When we are talking about the energy landscape, we are talking about power generation, in transport sector, heavy industries, building, construction, and so on. And all of this, if they want to decarbonize, and if we all agree that renewable power generations are the source for a clean and decarbonized energy system, then we need to electrify as much as possible. But electrification alone cannot answer all the problems. So in order to really utilize electrification in other sectors beside power generation, we need to have a medium or means in order to transfer or couple this power generation to these sectors. And hydrogen happens to be the right medium or the right means. As a means for energy storage, we can store the renewable power by producing hydrogen from the surplus of the renewable power generation in hydrogen, and then we can store that hydrogen and transport it to the point of use, or we can use it as a fuel itself. And because of the diversity that hydrogen brings with itself, it appears to be one of the strong candidates in the area of decarbonized world going forward. And that is the reason that there's a huge interest on that. And if we really want to have a low carbon or decarbonized hydrogen as a part of our economy, then we really need to focus on two ways that we can produce hydrogen. And one is producing hydrogen via electrolysis of water using renewable power generation, which doesn't emit any CO2 in its all value chain, or we can continue producing hydrogen from fossil-based sources and then couple that process with a carbon capture technology. And when we do that, even more than 95% of that CO2 that is associated with that process can be captured and stored permanently underground, for instance. So there are areas that we can even produce hydrogen from fossil-based sources, and at the same time help to decarbonize the whole economy with that.
So carbon capture and storage is not yet developed on a mass scale. That 95% figure that you mentioned, is that fair to say from that 95% that we're really on the path of making hydrogen fuel become renewable, that we're only 5% of the way forward?
Let me explain a little bit further about carbon capture. There are different technologies associated with carbon capture. When we talk about carbon capture, usually we are talking about 3 or 4 different type of technologies. For example, one type is capturing carbon from a source of a stream of gases that they have huge concentration of the CO2 in it. And usually when we produce hydrogen from fossil-based sources, basically what we do, we reform the methane by chemical process and produce carbon dioxide and also hydrogen from a CH4, for example, which is methane. And then that stream of the gases that combines hydrogen and CO2 is usually very high, with high concentration of CO2. If we decarbonize this stream, we are using a carbon capture technology that is suitable for that. And no matter how you are doing that, usually the capture rate, it can be beyond 90% or 95%, meaning that from that stream, 90% or 95% of that CO2 can be captured.
We have the technology now?
Yes,
and is it affordable?
Yes, it is. We have that technology. It is deployed. We have it at some commercial scales. It is not massively employed or deployed at a global level, but the technology is available and it can be deployed. Of course, you know, the cost associated with that decarbonization needs to be attractive for our customers and for the people that they are looking into decarbonized hydrogen. The thing about the energy transition is that besides having the technologies ready in order to achieve decarbonization, we need to have a kind of supporting mechanism from governments in order to really provide supporting policies to advocate for that decarbonization topics, for instance. At the moment, we do not have a defined strategy or defined policy from the government that they are supporting the additional cost that is associated with the decarbonization of the hydrogen that is produced from fossil sources.
Okay, now before we get into the issue of costs and also the other carbon capture technologies you wanted to talk about, let me bring Ali Safari into this discussion. Ali Jan, you said that you used to think that nuclear and nuclear fusion will deliver us from all evil, but now you're looking at how our power grids can better operate to bring different forms of energy to different markets. Will you consider taking on Fatemeh's challenge of adapting our distribution grids to a hydrogen-based economy? Does that seem feasible to you, given what you've heard?
I think not necessarily to a hydrogen-based economy. I think just adapting the distribution grid to operate in the future is going to be really challenging. You know, the electricity system is designed in such a way that supply needs to match the demand almost in real time at any given moment, right? In the past, the operation of the power system was very simple. You had a bunch of coal power plants, you had a lot of nuclear power plants, you had gas-fired power plants, but you could just schedule the generation, right? And for example, and the demand was very simple. You know, people didn't use electricity in unpredictable ways, right? But what's happening right now is on the supply side, you've got, you know, in a sort of a handful number of, for example, coal-fired power station or nuclear power station, you have hundreds and hundreds of solar farms. Like if you're driving around the motorway in the UK, you might see them, you know, beside the roads. And also you have, you know, hundreds and hundreds of like windmills, which actually are generating electricity. But then, you know, the wind doesn't always blow, and then the wind always doesn't have the same speed, or the sun doesn't always shine. And then what you have a source of electricity which is discontinuous, which is probabilistic. But then on the same side, at the same time, you know, on the demand side, consumers are, you know, starting to generate their own electricity using sort of rooftop. They are storing that electricity. If you have a Tesla Powerwall, for example, you know, you store that electricity in a Tesla battery, or like Sonnen, which you know, which is a shell company now. You start storing that electricity. And then also you have algorithms which you can start using that electricity in such a smart way. So both the supply and demand is being disrupted and becoming more dynamic, basically, right? And then the grid which we had and which was designed in 19th century needs to operate in this future. How they're going to do that, right? So there is no, you know, I think all of us, we agree, or to a certain degree, we agree that the future is electric, is power. You know, we're going to be generating electricity from cheap sources, for example, wind and solar. If you have you know, an excess amount of electricity, we can turn it into hydrogen, sure. But you know, the electricity needs to travel from when it's generated to when it's needed, and that is through the grid, right? And the grid doesn't have the capabilities to operate in this future world, which is very dynamic, which is very unpredictable. And there are various different technologies out there. Hydrogen is one. There are various different technologies out there which they are trying to make the grid more flexible. And by flexibility means the ability to absorb electricity when it's available, and actually giving it back to electricity, to the power system when it's needed. And hydrogen is one technology, but I don't think it's the only technology which is going to be that future. So it's in a
power
very
source is most adaptable to the architecture of our power grids today.
What do you mean by adaptable?
That you can, you know, if you want to have a more flexible power grid, which is there a way to, is the way to look at it is to look at solar, wind, hydrogen, all these other different sources of energy. Which one is better suited to this power grid that we want to change and adapt?
It's very simple. It's literally simply it's a matter of control. If you have control over how much you can generate, you can basically operate that future, right? And the sources that we have control over, the clean sources that we have control over, are hydro dams. And then we also have the source, so pumping electricity up the mountains and actually bringing it back when it's needed. We have control over that. But then, of course, you know, they're not going to be generating adequate amount of electricity, which we need to live our day-to-day lives, right? And then the other source of electricity, or the electricity generation, which we have a lot of control, is actually gas-fired power stations, which of course is not renewable. It's gonna have a lot of, you know, emission. So I think, you know, there is a lot of talks about battery storage, that we can actually, you know, bring that flexibility to the system, including, for example, you charging and discharging your car in such a smart way. You are storing electricity in your houses in a smart way. So in the past, if you had a smart battery in your home, it was single charge, single discharge. It was the electricity was cheapest during the night, so you would charge your battery during the night, and actually you would use that in your home during the day. But right now it's multiple charge, multiple discharge. So the grid is becoming more dynamic. For example, in the UK, and you know, is the challenge of running the grid, running the power system, is literally just going to become more complex and more chaotic as we have more renewable sources sort of like coming onto the system, basically.
Mm-hmm. Well, Elham, let me bring you in. We can go on all day about talking about a wonderful range of renewable energy sources at our disposal and how to optimize and adapt our power grids. But if these ventures are not reliable and are not affordable, then I guess there's no point. So if I'm one of those 800 million people in the world who doesn't have electricity to even switch on a light in my house, should anything of what we've heard today give me hope that my future can be one of reliance on clean and renewable energy?
Absolutely. I've always been thinking that for the last, 60, 70 years, the developed world has been going towards designing technologies that have taken the world much advanced in terms of tackling power and electricity problem. And for low-income countries and developing countries that are struggling with supplying sufficient amount of electricity to power, different uses of electricity in their countries, they can easily jump over and just start utilizing the technologies that didn't exist 50, 60 years ago. Now, for these countries, it's not a matter of luxury. I mean, I don't like really to use this word, but decarbonization is something that you might have to do it over a long period of time. It's not a matter of life and death today. Whereas in these poor countries, let's say, give you examples in African countries, anywhere sub-Saharan, we'll see this people that are severely struggling, both from business point of view, from healthcare point of view, from education, in every single principle of life. As Martin Jean mentioned, this is something that they could, provided that, as you mentioned, the systems are designed in a way that they're affordable and there are enough investments ready in place to help them to materialize this project, they could easily do a leapfrog and get into a level that will be ready to do, a lot of, witness a lot of economic development. Now, with regards to your question, the current technology, I mean, the technology apparently is there, and as it exists, is cost efficient and cost effective enough. But it's just a matter of stimulating the other side of the game. When I mentioned about the travel that I have to Africa a couple of years ago, talking to all of these developers, mini grid developers, they were complaining that we secured the finance, we got the technology, but then the electricity that is produced, there's not enough demand from the other side. And that brings all sorts of problems for itself. So it means that at the end of the day, if you want to invest in a project, you just need to make sure that there is an end user, there's someone that is ready to pay for that electricity. So a lot of these developers are actually getting into the productive use of the electricity business, in a sense that while they are having off-grid power plants built, they are also investing in local businesses. I mean, those local businesses could be as small as a little, milling, machine, or like a barber shop. It doesn't have to be anything massive. So we have that. And then also we have this incredibly, successful international companies that are, setting up shops in Africa, in low-income countries. But talking to their CEOs, there was a report by the UN that these CEOs were complaining that we are only performing at 30–40% of our capacity. And the reason for that is we cannot predict when there's going to be a blackout, and we just cannot predict how long that blackout is going to take. And we talked about battery, for example. Battery has been and will be one of the most optimal solutions for purposes that seems not to be right for the current situations, for example, in these low-income countries. Whereas hydrogen, as it appears, I mean, there has to be a lot of more research and R&D work to be done to sort of evaluate the difference of different solutions. But as for the hydrogen, the fact that it offers you the possibility of generating fuel and also storing that power for a longer period of time and at a higher density, that gives a lot of security of supply to the demand side. So it means that if I'm going to be buying electricity from our off-grid system, if I'm like Coca-Cola in Africa, then if I'm going to be given the promise that in the event of blackout, I'm going to be having this hydrogen tank, which is going to supply my, electricity for the next almost 1 week or 10 days, then this is something that they will most likely rely on. Don't forget that in these countries, the new wave of population growth is coming from Africa. In fact, they're calling Nigeria the new China. So in a matter of 10 to 15 years, you'll see that 2 billion people, based on the UN estimates, are going to be, are going to come from Africa, sub-Saharan countries, Nigeria, Tanzania, and those people first need jobs. And for that, you need to have a lot of economic stimulus for which you cannot eliminate electricity. So that's for my part for now.
Okay, so let's come out of Africa and talk about those 7 billion people who do have access to energy and infrastructure, but need to find ways to bring all these ideas of renewable energy to our power grids. And Samira, I know the science of power grids is a whole vast knowledge in itself. It's just a question of upgrading grids and finding cheaper ways to do this. Are there any game-changing thoughts in the pipeline, or it's just a matter of doing best with what we have now?
No, sure. There is going to be, I think, a big or large, huge change in the way that we actually produce and consume energy. And with all due respect to Ali, I would say that the future of our energy system is not going to be only power and electricity, but it is going to be a low carbon and hopefully at some point decarbonized system where we use different means to produce energy, and electricity is definitely one of the main ones, is one of the main energy carriers. We can also have molecule-based energy carriers such as hydrogen or other type of fuels that are hydrogen-based and are produced in a clean way, as Martin has explained. With electrolysis of water, and then with renewable energy. So yes, we need actually to change the infrastructure. We need to expand the capacity of the electricity grid to be able to actually accommodate all these large penetration of renewable energy. But again, as Ali mentioned correctly, we have these two main issues with renewable energy sources, especially solar and wind, that they are not available at all times, and also the mismatch between supply and demand, especially, for instance, in North Europe or West Europe, where we have cold winter, so we really have a high peak demand for energy, but we don't have enough sources to produce that energy that we need. And right now that is compensated by using natural gas, of course. So that needs to also be replaced by something else. And that's where hydrogen, or again, these molecule-based energy carriers come into picture, where we can not only use surplus energy, renewable energy to produce them, but we can have dedicated wind parks or solar farms to produce hydrogen and then store it very cheaply. Of course, batteries are very good for storage in many places for day and night balancing, let's say, or even if we are in places with lots of sun all over the year, we can even use battery for storage. But in most of the places, that's not the most economic option. It's very expensive. We need very large, huge systems for storage if we're going to use batteries. So that's why we can actually use hydrogen to store energy. And then when we need it and where we need it, we can convert this hydrogen back to electricity, as well as using it in different sectors. What I would like to add is that hydrogen right now is actually widely used in industry. So we use hydrogen in petrochemicals, we use hydrogen for ammonia production, and also in refineries. But as Martin said, right now mainly it is produced from natural gas or coal, so it is fossil fuel based. And we can actually replace this hydrogen by green hydrogen, which is produced from renewable energy. And but there are a lot of other aspects where hydrogen can play a role. We can also use hydrogen for transportation. We have hydrogen fuel cell cars, We also have lots of buses and trucks and heavy vehicles that are and can be run on hydrogen. Ships can be run on hydrogen. Trains.
In aviation with hydrogen?
Yes, also for aviation, they are actually looking, for example, now Shell is in one of the scenarios that they have generated is that they can also use hydrogen, for example, to produce synthetic kerosene, or in a way they can come up with other type of fuels that's hydrogen based. So it can be used again also for aviation and for drones and for all of this. So for transport, hydrogen can play actually a big role in decarbonization of our transport system. Battery cars are very good for, you know, the urban use, but when you want to go long distance, you cannot do that with batteries. You cannot charge your car every couple of hours and then wait for a half an hour to have a charged battery, while you can refuel your hydrogen tank after every 500-600 kilometers for less than 10 minutes.
I would disagree with that because, you know, for example, let's look at BP or let's look at Shell, right? They've invested on BP ChargeMaster. Shell just bought New Motion. You know, the rapid EV charging market is actually expected to grow to £56 billion by 2026. There's a race right now, as we speak, in the UK market, which I'm most familiar with, on finding optimal locations to actually install rapid EV chargers, right? Because that's a real market which is evolving. And for example, Centrica, one of the largest energy companies in the UK by market share in terms of retailing electricity, and they have plans to electrify their entire fleet with electric vans.
No, that's right. So I completely agree with that. So it is
I think hydrogen. I think hydrogen has a role to play. I think maybe that role is more to do with medium to long term, but I think short term we would really see a huge uptake of electrification of transport in particular, maybe heat, because I see lots of startups which they have a lot of innovative ideas on how to electrify the heat. And I think, you know, I think maybe in the medium to long term, we see a role that hydrogen has to play in the power system. But I think in the short term, definitely the answer is power. So the answer is electricity. And there are lots of different sort of market signals that we see happening already that indicates that's the case, basically.
Is that what you're saying? Is that an economic logic or a scientific logic? Are you saying there's just not enough money, not enough will to invest in hydrogen or other kinds of...
No, the point is right now the hydrogen production is still quite expensive, and the reason for that is because it's not on mass production. So as soon as we start having mass production, the cost of electrolyzer and also hydrogen production will be low, and based on all the recent reports from International Renewable Agency or the other European agencies that are doing all this kind of research on hydrogen and hydrogen economy, it's expected that by 2030, actually, green hydrogen, which is produced from clean electricity, will be compatible price-wise with blue hydrogen, which is the hydrogen that is produced from fossil fuel, but combined with carbon capture and storage. So this shows that in the, let's say, over time, we will have this, and I never say that it's going to be this or that. All these together will build our future energy system. But what I wanted to say is that actually, so the point is hydrogen can play a role in all different sectors and help to accelerate the decarbonization of all these sectors. So for instance, in industry, we can also use hydrogen for high temperature heat and steam. And that can be used also in a lot of places where they use natural gas, so they can replace that by using hydrogen. For power generation, as Ali mentioned, one of the ways right now is to use the gas power generation. And that again is something that will be replaced or can be replaced by hydrogen if they just change the gas turbine with hydrogen turbine. And that's, for example, what's happening in the Netherlands in one of the power generations.
Samira, I hear you guys are talking about this. Your mechanics are, you have all the, it seems to me, being the layman, that the solutions are there, that we have the technology, and it's just a question of money and will. What I read
I
was
think
after the
Siavash,
Paris Agreement.
yeah, I think at the end of the day, money talks in the market, right? So I think a technology will be a winner, which is going to make like commercial sense. I think when, for example, even the renewable itself, if you roll back to, let's say, like 10 years ago, there were talks that, hey, let's bring the government in particular in the UK. The government came in, gave a lot of subsidies to renewables to actually make it commercially competing with other sources. And nowadays we see renewables in the UK, for example, solar, which are subsidy free. The government has completely cut the subsidies for the solar. And then there's actually a race which is happening right now in developing subsidy-free solar projects in the entire UK. And the size of these projects are 50 megawatts, which is like, just to give you perspective, is 250 acres of land or 250 football stadium. That's the size of projects
Ali,
which is
on
being
top of
developed.
what you're saying, I read that after the Paris Agreement, just in the past 5 years, when we're supposed to be tackling the climate crisis, over close to $3 trillion has been invested in just fossil fuels. So, Fatemeh, Matinjan, what do you think? I mean, we don't want to go on about the hydrogen, the feasibility of hydrogen. Let's just talk about the possibility of making it become a viable source of energy. Given your closeness to the industry, do you see those kinds of investments necessary to come in so that by, let's say, 2030, we can achieve some of those objectives that we have in decarbonization?
To answer short, we should find a way. And you are absolutely right. In 2015, 192 countries unanimously agreed that they are going to collaborate together in order to achieve the Paris Agreement goals, which is really limiting the temperature rise, the global temperature rise, to 2 degrees centigrade, and ideally 1.5 degrees centigrade. And currently, we just exceeded, in 2019, we just exceeded 1 degree centigrade temperature rise, global temperature rise. And that was the driver behind so many countries that last year they committed to achieving net zero emissions by 2050. And if these countries, that the UK, for example, is one of those, and even they put it as a law for the country that by 2050, this country and also countries in European Union, except Poland and some other non-European countries also, if they want to achieve this net zero emission by 2050, they need to do the investment, and also they need to put supporting mechanism behind these new technologies that make this goal achievable, make this target achievable. And I think they are doing it in a right way. Coming from industry, I have to say that in order to serve our customers, we need to come up with a solution that it is economically sensible for our customers. Otherwise, the customer would fall back again to the usual way of doing their businesses, because it doesn't make sense.
What about government to make it more?
Absolutely. And if economic mechanism is not enticing or is not motivating for our customers in order to replace their conventional technologies with new decarbonized technologies, then there needs to be another force that can come by a stringent regulation, for example, from the government, or from a supporting mechanism like what they did for offshore wind or for solar power by providing subsidies. And if you remember, when I was introducing myself, I said that also I'm helping the UK government as a part of Carbon Capture Advisory Group to come up with the right business models in order to really deploy carbon capture at a scale in this country. This is what governments at the moment they are focusing on. They are really looking into areas whether they can introduce subsidies or introduce some business model to lift up the extra money burden that these new technologies would force on the provider in order to really accelerate the deployment of this technology at a scale. The promise of net zero just been introduced to the world last year. And usually policies take 2-3 years in order to be formed. So we are in the formation phase, and I expect that in a year or two from now, we are going to see and realize new policies that will be introduced, especially from these countries that they are committing to net zero, in order to support these decarbonized technologies going forward. For instance, talking about hydrogen, now EU, for example, they are just introducing a Green Deal, which is a very attractive deal, and that has a lot element related to hydrogen in it. And in order for them to realize that, they need to first recognize hydrogen as a fuel, right? It hasn't been for so long considered hydrogen as a fuel. So, but now we are seeing the change of the wording that they are using for hydrogen. Hydrogen so far was not considered for fuel because the appliances were not certified to be burning hydrogen, for instance. But we are now seeing the change in the tone,
the boiler, I think there's talk about making the boilers run on
exactly,
hydrogen
exactly.
by 2025. Elham, let me go to Elham. Elham, we talked about government, we talked about investors, but the role of fossil fuel companies. I'm still myself a bit intrigued about this. You're the closest as can be to the fossil fuel industry. You know how their mentality works. You've written a book on the geopolitics of gas in the Middle East and so on. Should we look at fossil fuel companies as our allies in trying, if there is any way to achieve, decarbonization, then it's these companies that should lead the path. Are they our allies, or they're actually obstacles in the way of making government and people, pushing them towards a better future?
Well, I think these days they are being forced to be allies, not necessarily by will, but by force. Look, I mean, you mentioned about the book that I've written in 2013-14, which was on natural gas. Back then, everybody was talking about natural gas because that was the cleanest and abundant source of energy that's, the world could have found. Because back then, solar and wind were so expensive that only, a few countries, rich countries around the world could afford integrating these type of technologies into, energy mix. Whereas in a matter of 4 or 5 years, in 2016 and 17, we started seeing power purchase agreements that were offered to, oil-rich countries like Saudi Arabia at offtake prices of 2.5 cents per kilowatt per hour, which is, it was for a lot of people unbelievable. So luckily, because of the advancement of the technology and mass production, the costs are going down. And historically, these companies, this is their root knowledge. This is what they've been doing for at least last 100 years. And this is where they get their geopolitical, their leverage power, basically. So for them, it's not necessarily something that they would be willing to willfully take on board. But I think at the end of the day, most of these, giants, they are owned by a lot of, impact investors, investors with concerns about which direction these companies are heading to. I'm sure you've heard a lot about, for example, a group of investors, Dutch investors inside BP and Shell, who are causing all sorts of trouble for their management team, just to make sure that they are writing off their most pollutant assets. So we can certainly now rely on them because, as was mentioned by both Samira Jan and Ali Jan, that they are also getting into a lot of clean tech acquisitions across the board, be it battery or hydrogen or carbon capture storage. So we will see that, but I think as we all agree, we are talking about a vision of 30, 40, 50 years. It's not something that could materialize immediately today or within the next few years, but we are looking at a transition towards decarbonization, but it's going to take a lot of time. I think it cannot, even with all sorts of government policies and big players, incentives and determination. It's just changing the behavior of the consumers, as Matija mentioned, changing the behavior of the companies who are ready to adopt that technologies and be willing to test them. But luckily we are on the right path, I think.
Okay.
If I have 2 minutes to add something to what Martina.
Very quickly, because 48 minutes.
I know. I was
to
just
close it up,
at
and we're just warming up, aren't we?
Yeah, but just like two things. One is that a lot of gas and oil and gas companies are also looking at basically introducing different type of fuels, including hydrogen. Aramco is the largest oil company in Saudi Arabia, and now they are. We had like 2 years ago when I was still working at Delft University, we had a meeting with them. And they actually wanted to hear from us what they can do and what are the existing technologies, how they can actually switch to use basically solar to produce clean hydrogen and then basically sell that. And saying that, I want to highlight the fact that we need still import of energy. We cannot produce all the energy locally in each country, you know, that can never happen. And we will never be really like energy sufficient in most of the places. And that's why, for example, in Green Deal, they also are going to initiate to 40 gigawatt, that they are the two, one is in Europe, but the other one is in South Africa, where they can actually produce, so basically wherever they have cheap electricity from renewables, like in North Africa, in Saudi Arabia, in Australia, they are going to produce hydrogen cheaply, and then they can import it to other countries for use. I mean, hydrogen or ammonia or a biomethane or whatever that can be based on hydrogen, but import of energy and of course the international collaboration is another important aspect. So I'm done.
Okay, so I'm hearing you all. We have the solutions, the science is there. The question of money is a big question, and it all depends on how much us consumers and investors are forcing the governments and the big companies to invest in this. I wish we could talk about this a bit further. I especially wanted to ask you guys about where you think we will be in 2050, how our lives will be different. Was it really when we turn on the kettle, or when we switch on the lights, or when we use the boilers? Is anything, as far as we know as consumers, is that going to be any different? We don't know what's going on, who is supplying it, or where the energy is coming from. Will we feel any difference, or our lives will more or less be the same? It's just the sources of energy behind our meters will be a little bit different. Just very quickly, a few seconds from each one of you. Alijan, what do you think? In 2050, how will life be different?
2050, I think our lives won't be different. The technologies that we will be using will be different. So I'll give you an example. Tesla has recently come to the power industry. They have made an interest in Europe. They've got this giant platform of smart power walls and etc. Then essentially you'll be the technologies that you'll have will be a self-sufficient producer of electricity. That you have enough electricity to operate your day-to-day life. But then the technologies will manage that for you. So as a consumer, you just put in your preferences, what you want to do, then an intelligent platform will act in a way that which is to your preference. So you won't be seeing or feeling any inconvenience in your day-to-day life. It's just the technologies which is out there will be very different.
Wow, the technology will be different. Difference in Matinjan, 2050, how do you envision that?
A huge electrification. Everything is electrified, and in our gas network there is only hydrogen. There is no natural gas, and I think people are driving electrical car, and for long distance vehicles we are using hydrogen-based fuel cells. And I think every people that they are living in this planet, they have access to free electricity. Electricity is one basic need, and everybody have access to that.
Elham, everybody will have access, everyone in Africa, all 2-3 billion of them in 2050?
I genuinely hope so. I genuinely hope so. Now, I definitely follow Matin's comment on this, and I think that's the path we are heading to.
Samira?
Yes, I also think the same, and we will have more decentralized energy systems, basically, where we can produce also locally or regionally, and also use different type of technologies to convert different sorts of basically energy carriers to each other to run our devices and to get the energy that we need.
Great. I think what we'll need most of all will be air conditioners, given that we'll probably be will be very hot by then. Thanks, guys. I'll pass on back to Arifeh and the rest of the gang for taking on questions that the rest of our participants might have.